Worksheet we're going to do very quickly because I already have it done. I'm just going to show you the things as we go. Is verifying identities worksheet 1. Always do these little guys in the corner somewhere or have another little sheet of them ready to refer to. All right. This one here, no squares, so I'm not going here. Next up is that I'm going to distribute. Because let's see these parentheses. So as I distribute the cosine, I am also turning tan and cotan into sines and cosines like I did here. And I'm canceling wherever I can, only on the left. So it's sine, it's cosine squared over sine. So now I need my common denominator. So I need another sine up here, sine squared, then plus cosine squared all over our common denominator of sine. And that's 1 over sine, which is cosecant x equals cosecant x. Check, done. Next guy. Here, oh, there's the square. So I'm thinking maybe eventually I'm going to use one of these guys, but first I got to figure this out. Hopefully you recognize tan and cotan as reciprocal functions. If you don't, then that's sine over cosine, cosine over sine, cancel, all the things, and it becomes 1. 1 minus cosine squared. So see the 1 positive? So when we come to this guy here, keep the 1 positive, minus cosine squared, that's sine squared. So we replace it with sine squared, equals sine squared. Check, we are done. Next up, this guy here, number 3. No squares yet, but I am going to FOIL this out. As I multiply this out, I do notice that they are conjugates. So I only need to multiply my firsts and my lasts. Then I'm going to check this guy out. Well, you can't see that anymore because I moved it away. So here's this. My secant is positive. Leave that positive. Minus 1 equals tan. Tan equals tan. Tan squared. Good job. Next up. No squares yet, but I see all these parentheses, so I'm going to FOIL it out. Again, conjugates. So it's just the first term squared minus the last term squared. Secant is positive here, secant positive, minus tangent equals 1. So 1 equals 1, check. Okay, number 5. Here's 5 and 6. Okay, here's 5 and 6. Let me slide this a little bit. Is that going to work? Oh, sure it is. Okay. Okay, so as I look at this guy, I need a common denominator, right? So I am going to take this 1 and I'm going to multiply it. You could even put 1 over 1 if you want to see it as a fraction. So you're going to need the 1 plus sine x, numerator and denominator. Fine. Now that I have it there, there's my common denominator. Go right across the top for your numerator. 1 plus sine x minus cosine x. Okay. Now, signs everywhere, even on the right, except for this guy here. Here's your problem. So that's the guy that we want to change. But I'm thinking I want to keep the negative with it. So as I look at my Pythagorean identities, here's my cosine. If I want this cosine to be negative, that means I'm bringing it to the right. So that's to the right. Let me bring the 1 to the left. Okay, and that's what negative cosine squared is equal to. So see how I just plug it in. So now I'm going to plug in my sine squared minus 1. Oh, look, I did a minus 1 and a plus 1. I kind of knocked it all out in one step. Sorry, condensed it. And then what I did was I saw here I have a common factor. Factor out that GCF. Numerator and denominator are the same, so we can cancel that. Now here's the thing. I know that we don't like to cancel when there's pluses and minuses. You can't cancel pieces of it, but if it is an entire factor together in parentheses, that's when you can cancel things. Sine x is equal to sine x. Here it is. Check. Over here on this side. Okay. Okay, so as I look where I'm going to tangent to tan x. I see sine over cosine as tan. So here's 1 tangent, and tan plus tan is 2 tan. That's why I'm thinking this side over here reduces to tan. Somehow I'm going to turn that into a tan. So make everything sines and cosines. Keep, change, flip. And that's why it's going to be the sine over 1. So sine over cosine there. Sine over cosine is tan. Tan plus tan is 2 tan. and that is equal to this. So I always want to kind of make the thing equal to itself, because it's as if I'm completing the left-hand side and it's finally equal to the right-hand side. Okay, 7 and 8. Oh yeah, you can see these. All right, cool. So for number 7, two fractions, different denominators. Let's make it a common denominator. The common denominator is both pieces together. The left side needs to be multiplied by the 1 plus sine x. The right side times the cosine x. Fine. So on the right side is cosine squared. These here, we're going to FOIL it out because they're not conjugates, because look, the signs are the same, plus, plus. So it's going to be 1 plus sine, so that's plus 2 sine x, sine, sine squared. So that's why we get this trinomial in the end, because we had to combine those middle terms, sine x, to give us 2 sine x. So now that I look at this, that guy there is 1. 1 plus 1 gave me 2. 2, and then we go back up here, plus sine x. Here's my denominator. I'm going to factor out this GCF of 2 because I kind of saw the plus and the sine, so I'm keeping it. If I factor out a 2, now these guys cancel. 2 over cosine is 2 secant x, and yep, that equals 2 secant x. Check, we are done. Number 8. As I look over here for number 8, oh, I'm sorry, this little arrow is like in the middle. That's annoying. So as I look over here for number 8, I'm going to rewrite my tangent, and then just so that I have, okay, so when I looked at this one, I did see that I wanted to have a denominator, and I could have left that as tan over 1, and then I stopped, and I was like, you know what, but tan itself is a fraction, why not just rewrite it as the fraction? So now I have this, and now it's very much like the problem before it, where we have to use both of these denominators, multiply them together to get that common denominator. So on the left, we are going to be multiplying times the 1 plus sine x, which means distribute, right? So that's why I got the sine x plus the sine squared x. And on the right, we're just multiplying by cosine top and bottom. There's my cosine squared. This piece together is 1. My entire numerator can be considered one factor. Doesn't matter if we are in the reverse order. It's a plus sign, and addition is commutative. So we multiply that. So now it's 1 over cosine, which is secant. And secant is equal to secant. Okay. About 7 or 8 minutes in. Let's keep going. I'm going to get through these quickly. Number 9. 9, 9, 9, 9, and 10. Let's focus on those. Okay. Two different terms. They need a common denominator. There were lots of different ways I was thinking of doing this. And in the end, I thought, you know what? Let me zoom in a smidge. Can I do that? Let's see. Is it going to let me? There we go. We'll do it that way. Okay. And then I thought, you know what? If I get my common denominator, and then I multiply numerator and denominator by the 1 plus tan, I already saw ahead that I would have a minus tan squared. And if this were in the numerator, I'd have a plus tan squared, and they go away because it's plus and minus are the same thing. So that's what happened. So then I was like, all right, you know what? So I'm going to rewrite this as something over itself, and that's the 1. So my common denominator is this. My numerator, they cancel, and 1 plus 1 is 2. So 2 over this, well, this is one of the identities. It's this one exactly, so that's secant squared. So I'm going to rewrite that denominator as secant squared. That comes up top as cosine squared equals, there's the coefficient of 2 cosine squared. Good. Number 10. Number 10, common denominator again. So I need both of these pieces. This plus has to go up here, and this with the minus has to go over here. And look, the signs cancel out, and that just gives me 2. Multiply this out, and the middle terms cancel because they're conjugates. This can be rewritten as cosine squared x, and then that comes up top, and there's your 2 secant squared x equals 2 secant squared x. Check, done. Moving on to number 11. Okay, no squares, so I'm rewriting everything as sines and cosines. Rewrite, same, rewrite. There's a sine squared. This guy needs to have a cosine on the top, and well, it needs the cosine on the bottom, which means I have to multiply cosine over cosine. That's why I get this cosine squared. All of my numerators are rewritten here, all over 1 cosine. And then I'm thinking, okay, was happening here. So I need to somehow fix this numerator, and you can kind of do whatever you want. But I just kind of looked at those first two terms, and I saw 1 minus cosine squared. So here with my identities, 1 minus cosine squared leaves me with sine squared. So I replaced this with sine squared. Now it's sine squared minus sine squared. That's 0. 0 in the numerator is 0, number 12. Note the square outside the parentheses, which means you need to write this twice and FOIL it out. When you FOIL it out, because it's the same sign in here, you will get 4 terms, and those 2 middle terms will combine. So it's going to be 2 secant tan. Now, tan secant tan, I don't really care. It's the same difference. Moving on. So there's your secant squared, tan squared, and now we want to know, because secant and tan are in the same family of guys, so now we want to do a little bit of replacing if we can. Whoops. Here's secant and tan. See this guy right over here? Because I have to bring down this plus 1, right? So I FOILed this out. 1, 2, 3 terms come from this, and then there's my plus 1. I'm going to get back to the denominator in a second, because that was a hot mess on my part. So I'm going to bring down this 1, and then I saw that this can be replaced with a secant squared x, which I have here, and that gives me 2 of them then. So I have 2 secant squared x minus this. Okay. Then I was like, wait a minute, since I have 2 and a secant and 2 and a secant, I can factor that out. Just seeing where it's going. So 2 secant x parentheses, leave one of the secant x's, minus tangent, because this guy came out in front. This is up here in the denominator. My original thought was to take the denominator and turn it into sines and cosines. And when it started to get messy, then I thought, you know what, let me hold off on that thought and see what happens. So as soon as I got this guy here in my numerator, here it is, then I brought back my original denominator. Here's my original denominator. I brought him back and decided to 86 that idea. So that's done. So this cancels here and here. So now what I had to do was take this 2 secant, so that's 2 over cosine divided by 1 over sine. Keep, change, flip this sign up top. Sine over cosine is tangent, 2 times tangent. Look, I ran out of space. So 2 tan equals 2 tan, because there's my 2 tan there. Oh, okay. We gotta move. We gotta move because I'm running out of time. So now this guy here. What did I do? Denominator. So see this big thing? I left my numerator the same. I'm only working on the denominator. So tangent is sine squared over cosine squared. Cosine squared over cosine squared is 1. Yet your common denominator. This. Right? So I turned everything into sines and cosines. This is my numerator. So I'm going to keep my numerator, change, and flip. And these guys cancel, and there's my cosine squared. Number 14. Turn everything into sines and cosines. I'm just going to let you look because I have to make this guy under 15 minutes, and I'm kind of totally running out of time. Here's number 15. The way I chose to do this one was I wanted to factor it as if it were something that looked like this, x squared plus 2xy plus y squared. And when that thing happens, then I take this guy, split him evenly, x and x, take my back guy, split him evenly, y and y, plus plus. And that's why your outers and your inners, which is xy, which is 1 of each, and there are 2. These each simplify to 1, and 1 times 1 is 1.